Stroke, a sudden calamitous blow. The brain is punched out from within. A blood clot or bleed in the brain's arteries cuts off oxygen to the brain's tissues, killing them. The most stricken of its victims end up mere shadows of who they once were, often warehoused in impersonal institutions, trapped in their bodies, fed like babies, unable to care for themselves, move, or speak. Stroke is one of the leading causes of disability in adults. Though it is most often affects the elderly, it can occur in people in their 40s or earlier. Doctors in an emergency room may be able to prevent a stroke from getting worse by unblocking the clot or stopping the bleeding. But once the damage is done, modern medicine is of little help, or was until Edward Taub invented his plasticity-based treatment. Until constraint-induced therapy, studies of chronic stroke patients with paralyzed arms concluded that no existing treatment was effective. There were rare anecdotal reports of stroke recoveries, like that of Paul Bacchi-Rita's father. Some people made spontaneous recoveries on their own, but once they stopped improving, traditional therapies weren't much help. Taub's treatment changed all this by helping stroke patients rewire their brains. Patients who had been paralyzed for years and were told they would never get better began to move again. Some regained their ability to speak. Children with cerebral palsy gained control of their movements. The same treatment shows promise for spinal cord injuries, Parkinson's, multiple sclerosis, and even arthritis. Yet few have heard of Taub's breakthroughs, even though he first conceived of and laid the foundation for them over a quarter century ago in 1981. He was delayed from sharing them because he had become one of the most maligned scientists of our time. The monkeys he worked with became among the most famous lab animals in history, not because of what his experiments with them demonstrated, but because of the allegations that they had been mistreated, allegations that kept him from working for years. These charges seemed plausible because Taub was so far ahead of his peers that his claim that chronic stroke patients could be helped by plasticity-based treatment seemed incredible. Edward Taub is a neat, conscientious man who pays close attention to details. He is over 70, though he looks much younger, is smartly dressed, and his every hair is in place. In conversation, Taub is learned and speaks in a soft voice, correcting himself as he goes along to make sure he has said things accurately. He lives in Birmingham, Alabama, where at the university he is finally free to develop his treatment for stroke patients. His wife, Mildred, was a soprano, recorded with Stravinsky, and sang with the Metropolitan Opera. She is still a belle with a magnificent mane of hair and southern feminine warmth. Taub was born in Brooklyn in 1931, went to the public schools, and graduated from high school when he was only 15. At Columbia University, he studied behaviorism with Fred Keller. Behaviorism was dominated by the Harvard psychologist B.F. Skinner, and Keller was Skinner's intellectual lieutenant. Behaviorists of the time believed that psychology should be an objective science and should examine only what can be seen and measured, observable behaviors. Behaviorism was a reaction against psychologies that focused on the mind, because to behaviorists, thoughts, feelings, and desires were merely subjective experience that wasn't objectively measurable. They were equally uninterested in the physical brain, arguing that it, like the mind, is a black box. Skinner's mentor, John B. Watson, wrote derisively, "Most of the psychologists talk quite volubly about the formation of new pathways in the brain, as though there were a group of tiny servants of Vulcan there who run through the nervous system with hammer and chisel, digging new trenches and deepening old ones. For behaviorists, it didn't matter what went on inside either the mind or the brain. One could discover the laws of behavior simply by applying a stimulus to an animal or a person and observing the response. At Columbia, the behaviorists experimented mostly with rats. While still a graduate student, Taub developed a way of observing rats and recording their activities by using a sophisticated rat diary. But when he used this method to test a certain theory of his mentor, Fred Keller, he, to his horror, disproved it. Taub loved Keller and hesitated to discuss the experiment's results, but Keller found out and told Taub he must always call the data the way they lay. Behaviorism at the time, by insisting that all behavior is a response to a stimulus, portrayed human beings as passive and so was particularly weak in explaining how we may do things voluntarily. Taub realized that the mind and brain must be involved in initiating many behaviors, and that behaviorism's dismissal of the mind and brain was a fatal flaw. Though an unthinkable choice for behaviorists in that era, he took a job as a research assistant in an experimental neurology lab to better understand the nervous system. In the lab, they were doing deafferentation experiments with monkeys. Deafferentation is an old technique used by Nobel Prize winner Sir Charles Sherrington in 1895. An afferent nerve in this context means a sensory nerve, one that conveys sensory impulses to the spine and the brain. Deafferentation is a surgical procedure in which the incoming sensory nerves are cut so none of their input can make this trip. A deafferented monkey cannot sense where its affected limbs are in space, or feel any sensation or pain in them when touched. Taub's next feat, while still a graduate student, was to overturn one of Sherrington's most important ideas and thus lay the foundation for his stroke treatment. Sherrington supported the idea that all of our movement occurs in response to some stimulus, and that we move not because our brains command it, but because our spinal reflexes keep us moving. This idea was called the reflexological theory of movement and had come to dominate neuroscience. A spinal reflex does not involve the brain. There are many spinal reflexes, but the simplest example is the knee reflex. When the doctor taps your knee, a sensory receptor beneath the skin picks up the tap and conveys an impulse along the sensory neuron in your thigh and into the spine, which conveys it to a motor neuron in the spine, which sends a impulse back to your thigh muscle, making it contract and making your knee jerk forward involuntarily. In walking, movement in one leg triggers movement in the other reflexively. This theory was used to explain all movement. Sherrington based his belief that reflexes were the foundation of all movement on the deafferentation experiment that he did with F.W. Mott. They deafferented the sensory nerves in a monkey's arm, cutting them before they entered the spinal cord so no sensory signals could pass to the monkey's brain, and found that the monkey stopped using the limb. This seems strange because they had cut sensory nerves which transmit feeling, not the motor nerves from the brain to the muscles which stimulate movement. Sherrington understood why the monkeys couldn't feel, but not why they couldn't move. To solve this problem, he proposed that movement is based on and initiated by the sensory part of the spinal reflex, and that his monkeys couldn't move because he had destroyed the sensory part of their reflex by deafferentation. Other thinkers soon generalized his idea, arguing that all movement, and indeed everything we do, even complex behavior, is built up from chains of reflexes. Even such voluntary movements as writing require the motor cortex to modify pre-existing reflexes. Though behaviorists opposed study of the nervous system, they embraced the idea that all movements are based on reflex responses to previous stimuli because it left the mind and the brain out of behavior. This in turn supported the idea that all behavior is predetermined by what has happened to us before, and that free will is an illusion. The Sherrington experiment became standard teaching in medical school and universities. Taub, working with the neurosurgeon A.J. Berman, wanted to see if he could replicate Sherrington's experiment on a number of monkeys, and he expected to get Sherrington's result. Going a step further than Sherrington, he decided not only to deafferent one of the monkey's arms, but to put the monkey's good arm in a sling to restrain it. It had occurred to Tob that the monkeys might not be using their deafferented arms because they could use their good ones more easily. Putting the good one in a sling might force a monkey to use the deafferented arm to feed itself and move around. It worked. The monkeys, unable to use their good arms, started using their deafferented arms. Tob said, I remember it vividly. I realized that I had been seeing the monkeys using their limbs for several weeks, and I hadn't verbalized it because I wasn't expecting it.